Okay, so this is the schematic with all the amendments made that I discussed earlier. So the next step is to translate this into a PCB design. So I've already started this process. We'll look at the PCB as it currently stands. So far what I've done is create the board itself, the board outline, that's the green line. And of course I've made this the size and shape that will suit the Altair. And I've also placed the edge connectors, there's one on each side of the board, in the correct position and orientation for the Altair. This is a two-sided board, so we've got a top copper and a bottom copper, and we'll also have a top silk screen, but we won't have a bottom silk screen. We don't need it in this design. The other thing I'm going to do on this board, and this is largely for performance reasons, is we're going to have a ground plane, or what amounts to a ground plane. So I've created that already, and that's this blue line. If I temporarily fill it with copper, then you will see that it covers most of the board area. So I'll remove the copper just temporarily. Now, because this ground plane is connected to our ground connection, that's the 0 volt connection, then it means we don't need to explicitly connect up all the ground pins on the chips. They can be connected to this ground plane without running tracks between them. So if I highlight the ground plane, or rather the ground connections or the ground net, everything currently highlighted in blue is connected to ground. But we don't need, as I said, to run individual tracks between these. They will be catered for by the ground plane. If you're not familiar with PCB CAD programs, then these yellow lines are representing all the connections that we have to make with copper track. And because we don't need to make these connections using copper tracks for the ground plane, then I can turn off these particular connections, and that will save a lot of time and effort laying tracks that we don't need to. So I'll turn off those particular tracks. So we just find ground, turn off the connection, apply, and we'll see that a lot of the connections have already disappeared. The next thing to consider with regards to laying out the board is the ease with which the board can be laid, the ease with which it can be manufactured, and the performance of the board. So on a digital board like this, then there's nothing really critical with regards to performance, other than making sure we don't run very long tracks when we don't need to. So this is really about laying out the components in a way that make the track laying as easy as possible. So there's no fixed rules for this, but what I'll do is I'll start with the two memory chips, and all we do is we drag them into the position that we want. We'll shuffle them around later. Now, you might see that these are fairly unusual footprints, and that is because I want the board to be able to support different footprints for these memory devices. They're available in two different through-hole versions. So that's the 0.3 inch and 0.6 inch pitch. And rather than having separate footprints in different areas of the board, which might get confusing, I've just created footprints that will cater for either type. So we'll start by placing those there. We might need to move things around and shuffle them about to get the best results. But what you're initially aiming for is to get as few crossovers in these yellow lines as possible, and that will in general make the board layout much easier. So we'll place that one there. So these are of course the buffer chips. We'll put that one there. So we're looking to get them in an order where we're not getting lots of crossovers, and that will mean we don't get a lot of tracks being put down that we don't otherwise need. So we'll place them fairly centrally. So we can see we've got connections coming up from the edge connector to these three buffer chips, and that's where most of the connections onto and off the board are made. So we'll lower those a bit further towards the edge connector. I don't want to go too low. And then we can lay out the memory chips in such a way that they give us a suitable minimal path lengths for the connections to them. We can see already that by laying out the chips like this, that the interconnection should be fairly easy to make. So what I'll do is align these so that they're in a dead straight line. And as we can see already, we're starting to look much neater with regard to the number of crossovers. So this chip here ideally needs to sit between these two, so we'll shuffle that one across, put this one down here. Okay, and as we're getting far more connections to the two chips over here, what we can do is actually move the memory chips further across to suit these. It will make laying out the board much more straightforward. This one is probably going to be better suited being here, so as you can see, these connections are much shorter if we have the two chips mounted like this. I don't particularly like them being offset like this, so rather than making it a bit unsightly in terms of a design, I'm just going to put these across here. It's up to you if you want to trade off appearance of the board for ease of connections, but it's down to whatever your particular preferences are, and as I say, in this case the performance of the board isn't really going to suffer either way. So I'll now line up these. So if you can, it's good to get them all lined up as neatly as possible. It does make the board look a lot better. Try and get the spacings as consistent as possible as well. Again, it makes the board look a lot better. Okay, and again, as we're getting far more connections from the two left-hand chips, I'm going to put the memory chips centrally over these two. So what I'll do now is I'll go through the rest of the layout. I'll probably speed it up through this bit or just jump through to where I've got it finished, and then we'll start looking at laying down some tracks. Okay, so that's the initial layout completed. As you can see, it's very quick, only took around 10 minutes, and it's going to be a very sparsely populated board, and that was always going to be the case. It's a very large board, but it's intended for the Altair. That's not a big issue. So now I've got the basic positioning of the components sorted out. The next step is to carry out any initial optimization of connections just to make life a bit easier later on. This thing down here, if you've seen my videos on dealing with noise on the Altair, then one of the things that's become apparent is that what really seems to help on the Altair is a filter on a lot of the power lines and signal lines. I'm not going to filter the signal lines, but I am going to put a small RF or high frequency filter on the positive power line on the way in to the regulator, and that should make sure that we don't get any high frequency noise and switching noise coming into the board. Most Altair boards have these, but they tend to be actual components that you have to fit to the board. Very small inductors, but I'm going to just create one on the copper layer here just to again cut down on the cost of the board, and simply because we have the space to do it. So I'm going to go and make these changes, and then I'll come back and we'll start laying down some copper tracks. I've just been going around tidying up the silk screen, making sure that the symbol labels are in the correct places, getting them aligned so that they look neat. As I said before, a bit of time spent just lining things up does make the whole board look much better, and doesn't really take that much more time. So far it's taken me about 45 minutes to an hour to get it this far, so you can see it really isn't all that time consuming for a simple board like this. Next step is to start laying down some copper, but generally before I actually start putting copper down, because once you start laying copper tracks it makes components much harder to move around. I may need to move some components around later on, but we'll see how we get on with this particular layout as it stands. But one thing you can do before you start to get some idea as to how the board will look and to visualize how the finished board is going to appear is to turn off the connections. It gives you a better idea as to how the particular board is going to look. Also on this particular CAD system I've got a 3D view I can pull up. It gives me a rough idea as to how the board is going to look. As you can see, it looks fairly reasonable. I don't think there's any real need to modify that. The only reason we need to move things around is if it just makes laying down some tracks easier. So I'll turn the connections back on and we'll start putting down some copper tracks. Now because we've got a backplane here, as I said earlier, I've turned off the ground net, so we don't need to make those connections explicitly, but we do need to check at the end that all the ground connections have been made. Sometimes you'll find, especially on dense boards, that there wasn't space to make a connection to the ground plane, or if the ground plane is not continuous, that's been, in other words, it's been cut by tracks or something, then certain areas might have copper filled areas, but that copper filled area might not be connected to the ground plane, so it's important to check everything at the end, and that will show as a connection that hasn't been made. What I want to do is keep as many of the connections on the top layer as I can, so that we keep the bottom layer as an intact ground plane. So I'll just start randomly. I'll start in the middle. One other point I'll make is it's a good idea on boards that have a long edge connector like this to keep the components nearest the connector a reasonable distance away. So in other words, keep this space open if you can, and it just makes running tracks across the board and then down to the connector that much easier. So we'll start laying down tracks. The other thing you need to decide as you start is what size, what width tracks you want, and the CAD system I'm using has specific ability to define tracks, and because this is not a critical board, I'm going to use fairly wide signal tracks. They'll be 0.3, 0.4 millimeters wide. It's quite wide as tracks go on PCBs, but we're not limited for space on this, and the wider they are, the more reliable your board's going to be. We just need to make sure it will fit between the pins without contravening our design rules. So as I move the mouse cursor over the pins, you can see that they're being highlighted and then a surround, kind of a halo, is being presented. And that is the guard spacing that I've set. In other words, I don't want to have anything encroaching into this space because when the board's manufactured, if there are things that have features smaller than this, it will either make the board more expensive to manufacture or it could make the board unreliable. One issue you get when you're trying to lay tracks like this is you'll get these connections that appear to be going across various pads, but they're not necessarily connected to the pad they're going over. So if you're not quite sure if it's connected to the adjacent pad, start the connection and then highlight the track, and you can see that in this case it is going to these pads but not to this one. So I'll start laying tracks here. Before I start, I've got the style selected that I want, but I also need to tell it which layer to put the track on. In this case I want it on the top copper, so I'll select the top copper. Okay, so I'll start here, highlight the track, and then just make the connections as they are shown. Okay, so that's our first set of tracks laid down. Okay, so that's the first few tracks laid down. I haven't encountered any problems so far. I'll fast forward through the next part of the layout, but so far 10 minutes in, it's not going to take more than probably an hour or so to lay out this board, and hopefully you won't find it too boring. Okay, so it took around 2 hours. The board is now fully routed. I've carried out all the design rule checks for all spacings and anything that's interfering. Checked that all the connections have been made, so we have no unrouted tracks or nets. And I can now produce the Gerbers and get a prototype board made. And then I'll post another video showing the initial assembly and testing of the board.